Hi guys, this is Miss Goal. Welcome to the first lesson of the year with Module 1, Lesson 1, Measuring Rate and Proportional Relationships. I just want to remind you that as you're taking notes, make sure that you write down any questions that you have or topics that you didn't understand right at the end of your notes in the section labeled Questions to Ask in Class / I Didn't Understand. And you'll have the opportunity to address these at the beginning of the next class. So if you have any questions you need to write down, you can just pause your video, write them down, and then continue. Your outcomes for today's lesson are students compute unit rates associated with ratios of quantities measured in different units. Students use the context of the problem to recall the meaning of value of a ratio, equivalent ratios, rate, and unit rate, relating them to the context of the experience. Students understand that two quantities are proportional to each other when there exists a constant number such that each measure in the first quantity multiplied by this constant gives the corresponding measure in the second quantity. And finally, when students identify the measures in the first quantity with an x and the measures in the second quantity with y, then they will recognize that the second quantity is proportional to the first quantity if y equals m times x for some positive number m. And they apply this relationship when using variable choices other than x and y. Let's take a look at our first example. In this situation, we had a class that was passing out papers and they timed in seconds how long it took them to pass out these papers. So notice in all of these in the first column it's all 24s because the number of students doesn't change, and then the time that it took them to pass out with the different trials. In our third column, we're asked to represent the ratio of numbers of papers passed out to time. And there's different ways to represent ratios. If you recall from 6th grade, we can write this as 24:12, which is actually read 24:12. Another way to write ratios is to look at the two numbers and see if you can create an equivalent ratio by either multiplying by a factor or dividing by a factor. So here I notice these both have a factor of 2. So if we divide 24 by 2 and 12 by 2, we get 12 and 6. And another way to write ratios is to literally write the word 2. So 12 to 6 is another way to write this one. A third way to write ratios, if we look at our trial 2, we have 24 and 11. So we could write this as a fraction, 24/11, which is still read 24/11. And these don't have a common factor that I can divide out, so I can multiply by a constant. Let's say we multiply both of them by 2, and that will give us 48/22. In the third trial, we could write this one as 24/10. Or I can realize that they're both divisible by 2 and write this as a fraction, 12/5, which is still read 12/5. And the last one, we could write it as 24:8, read 24/8. Or I could realize they're both divisible by 4, and so I can divide them both by 4 and get 6/2. In our next column, they're asking for a rate, and I can choose any of the ratios that I've created or create other ones. Let's just pick some off of the column that we just created, and the difference between the ratio and the rate is the rate is going to involve the quantity. So with this one, we could say 12, that represents papers, per 6 seconds. So basically saying that they could pass out 12 papers for every 6 seconds. In the next one, we could use the 24 and 11, meaning 24 papers per 11 seconds. In the next one, we could use the 12/5, so this would be 12 papers per 5 seconds. And the last one, let's use the 6/2, so this would be 6 papers to 2 seconds. Our last column is asking for the unit rate, and when they say unit rate, they're talking about the quantity on the bottom needs to be a single quantity. And we can achieve that by just dividing our numbers. So in this one, if we did 12 divided by 6, that gives us 2 papers per second. And notice this is a single second, so that's why it's considered a unit rate, because it's a single quantity on the bottom. When we divide 24 and 11, we're actually going to get a repeating decimal. So anytime you're going to get a repeating decimal, you should just write it as a fraction. So let's just leave this as an improper fraction and make it 24 over 11 papers per second. I didn't write it as a repeating decimal because at some point I would have to round, and so that's not really an exact unit rate. With this one, when I do 12 divided by 5, we actually get 2.4. So since that's terminating, I'm going to write that one as a decimal. And the last one works out nice with 6 divided by 2, giving us a unit rate of 3 papers per second. Okay. And so this really just reviews some of the ideas that you talked about in 6th grade. Let's take a look at example 2. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based on the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed their dishes, and this is what they found. So we have a table of their results. We have their weights and then the cost of their ice cream dish, or their frozen yogurt dish rather. Now if you just think about this scenario, when you go to a pay by the ounce yogurt shop, what they're going to do is they're going to weigh it and they're going to multiply that by a certain amount, which is what you pay per ounce. So if we wanted to figure out what that ounce was, we know that normally we'd multiply, but we have the results, the input and the output, so we're going to work backwards. So we're going to take the output so that we can find the cost per ounce, and that's going to give us our unit rate. So we want to take the cost, in this case was 5, and the ounces was 12.5. And we divide those two, we're actually going to get 40 cents per ounce. So each one of these is going to be basically multiplied by 0.4, 4/10, or 40 cents. So here we can check to make sure that this works. If we multiply 10 times 0.4, we get 4. If we multiply 5 times 0.4, we get 2. And if we multiply 8 by 0.4, we get $3.20. So you'll notice that this works for every single one. And so this really answers our question, does everyone pay the same cost per ounce? In fact, they do, and that really only makes sense. It wouldn't be fair to charge one person more than another person. So our cost is going to be a unit rate of 40 cents per ounce. Now, how we can use this, take a look at our word problem down here. Isabel's brother takes an extra long time to create his dish. When he puts it on the scale, it weighs 15 ounces. If everyone pays the same rate in the store, how much will his dish cost, and how did you calculate this cost? So we know that we take the number of ounces and multiply it by the cost per ounce, which we already found to be 40 cents per ounce. So we can do that. 15 times 40 cents is going to give us an output of $6. And so this is a way that we can use this. Okay, let's take a look at our last example here. In the back of a recipe book, a diagram provides easy conversions to use while cooking. And they have set this up with a double line diagram. So we know that 0 cups relates to 0 ounces, a half a cup relates to 4 ounces, and so on. And that's really what the diagram is telling us, is if you have a certain number of cups, what is the equivalent number of ounces? And we could work both ways with that. The next thing we want to discuss is the number of ounces proportional to the number of cups, and how do you know? Now, the idea of being proportional, we actually identified this in the previous example. So if we just go back for a second, you'll notice that in each one of these cases, every single one of our inputs of ounces was multiplied by a constant of 0.4 to get our output of cost. Since every single case is going to be multiplied by that constant, that makes this proportional. So we have to decide if this is going to be proportional, meaning is it always multiplied by the same number? So the easiest way to look at this is actually to identify, in this case, we have a unit rate right here. Notice here we have 1 would have to be multiplied by 8 to get us 8. So let's see if that works in the other one. So 1/2 times 8 does give us 4. 0 times 8 does give us 0. 1 1/2 times 8 does give us 12. And 2 times 8 does give us 16. So that confirms that this is a proportional relationship and that cups is proportional to the number of ounces. So that tells us that 8 ounces per cup is our relationship. How many ounces are there in 4 cups, 5 cups, or 8 cups? How do you know? Well, if we know that every single one of our cups can be multiplied by 8 to get the ounces, we really can just multiply each of these relationships by 8. So 4 times 8, 5 times 8, and 8 times 8. So you guys can figure that one out. Now notice that every single time what I'm saying to you is you're going to multiply the number of cups, which is our input, so let's call that X, by 8 to get our output of ounces Y. So the equation that we can use to represent this is Y equals 8 times X. So it's saying to multiply the number of cups by 8 to get the number of ounces Y. In this lesson, you have learned that unit rate is often a useful means for comparing ratios and their associated rates when measured in different units. The unit rate allows us to compare varying sizes of quantities by examining the number of units of one quantity per one unit of the second quantity. This value of the ratio is the unit rate. Measures of one quantity are proportional to measures of a second quantity if there is a positive number k, so that for every measure x of the first quantity, the corresponding y is given back k times x. The equation y equals k times x models this relationship. A proportional relationship is one in which the measures of one quantity are proportional to the measures of the second quantity, meaning that they're always multiplied by the same constant to get the output. In the example below, the distance is proportional to time since each measure of distance y can be calculated by multiplying each corresponding time t by the same value 10. So notice here, 0 times 10 is 0, 1 times 10 is 10, 2 times 10 is 20, and 3 times 10 is 30. This table illustrates a proportional relationship between time t and distance y.